I will not speak about printing dildos. You can find it on internet. I will speak about how to use printer at home, 3D printer. So first, come on, stupid computer. Okay, my computer's stuck. Okay, here we are. So first, you need to get a 3D printer. As you can see here, I built my 3D printer by my own during the workshop driven by Mr. Josef Prusa, who is the probably most well-known guy in 3D printing world now. And my recommendation is, if you build your printer yourself, you will know how this printer operates, and you will be able to print something. If you buy a finished printer, I don't know, for example, a Replicator 2 from MakerBot, you spend a lot of time to learn how to print. It doesn't, 3D printing really doesn't work as a printing on paper. So you need to know how it works, you need to know how to calibrate your printer, and you need to know how to prepare 3D models. So it is not like a printed document from some text editor. So if you buy a printer from some vendor like MakerBot, you spend a lot of time to learn how to print. It's not really so easy how those companies tell. It really doesn't work like a printing on the paper. Of course, there are a lot of different kinds of the 3D printers. I will speak about this one. It's a Prusa Mendel i3. It's from RepRap project. You have some different kinds of the printers using the different technologies, and it's much easier to print, for example, using the technology. There is a technology using the powder. So you make layers from the powder, and this powder is vytvrzovan. Oh, how to say it in English? The laser make it hard, and it's much easier to use those kind of the printers. But the price of the printer like that is 10-20 times higher than this one. This one is around 1,000 euro. If you want to have this powder one, you will pay 10,000, 20,000 euro, at least. Sorry? Yes, this is the one. And the material is damn expensive. The price of this material, I will speak about it later, it's around $30 US per kilo. It costs almost nothing. So my recommendation is build your printer yourself, because you will learn a lot of how it works, how to operate it, and how to maintain it. Okay. So I spent 1,000 euro. So second step, you must have some excuse to have some device like that at home. So you must repair something at your home. So this is the broken part from the bath. This is the part opening the sink of the bath, and it was almost impossible to buy it on the market. I spent a couple of weeks working around and find a place where to buy it. So the much easier way is to print it. So before you start printing, you need a 3D model. You can create your 3D model by yourself. My favorite software to making a 3D model is the OpenSCAD. I'm using the OpenSCAD because I'm a developer. And if you look to OpenSCAD, so OpenSCAD, you have some kind of the programming language, and you really program the 3D part. So it's much easier for me because I'm a developer. Of course, you can use any other stuff. By the way, this is the part I printed for my mother because she has the broken shower. So you can use almost any system or any application for 3D modeling, but this application must export to STL format. The STL format, stereolithography, is some kind of 3D model which is absolutely independent on any platform. I think the quite good application is Autodesk 123D Design or Catch. It's for free. It's made by Autodesk, so the Autodesk is Autodesk. And it's a really stuff for 3D modeling. But I'm preferring the OpenSCAD. It's much easier for me to use it. So here you can see the part for this sync opener. And as you can see, it's just few lines of the code. You can see I have some cylinder, another cylinder, I make difference of them. So it's a very simple language. So you have a lot of primitives like cylinder, cube, and so on. And you have some, let's say, mathematical operations to put it together or make some difference or make some intersection and so on. So after you have a 3D model in STL, and one moment, if you want to print something just for fun, so just go to ThingGivers web page, and there you can download a lot of 3D models. So for example, the very popular, do you know GoPro cameras? Do you have fun? Someone of you? No. The equipment for GoPro cameras is damn expensive. So just type GoPro. And you have a lot of stuff for GoPro for peanuts because the printed part costs nothing. So you can find here a lot of 3D models just for fun, just for real stuff like the GoPro camera and so on. After you have a model in STL format, you must convert it to Gcode. The Gcode is printer dependent, and it's a real commands for the printer. If you look here, this X129 something, Y and so on, it really means where to move printer head, and this E means how much plastic you have to extrude. That's all. This Gcode is very similar to some drilling machines, so it's the same system. To convert STL to Gcode, the most common software is Slicer. So Slicer converts STL to Gcode, and this Gcode is really printer dependent. So how it works? So I open Slicer. It takes some time. This application needs a lot of resources. So I open some model. Okay, and here you can see the settings for the printer. And those settings, it's a real dark magic. So you really need, this is really printer dependent. So you need to learn a lot of stuff, how printer works, to be able create your own setting. There are at least 60 parameters you can set, and this is the the most problematic part. If you have some issue here, you will not be able to print. So I made this model a little smaller because it takes a lot of time to print something like that. Okay. Export Gcode. I did it 70%. Okay. And the result now is a Gcode. So the next step, let's start printing. There are a lot of software to control the printer. I am using Repetier. There are much more of them. This is my favorite one. And this printer, this software is really connected to the printer, so you can control printer manually. Here you can see I am heating the extruder. The extruder is the very hot part. You can see it has 245 degrees. It's not really nice to touch it, I know it. Then we have a printer bed. This is this part I'm printing on, and it depends if you need to have a heat wand or not. So I am using for this material is ABS. The ABS is most common plastic, so almost
Lego, right?
yeah, Lego is ABS. It's metal, so almost all plastic you can find is ABS. So I sent you a piece of this. If you are a very orthodox user of 3D printers, you will use plastic named PLA. PLA is made from the corn. It's not a plastic. It's made from corn. So if you throw it in the nature, it disappears in a couple of months. This printer, thanks to very powerful nozzle and heating, can print from polycarbonate. Polycarbonate is used for bulletproof windows or nylon. So you can print your own nylon socks, for example. The problem is the nylon polycarbonate is during the printing it produces some exhalation which are not really good for the people. But if you print from ABS or PLA, you can print in living room. It doesn't smell really. So if you are printing on PLA, you don't need to use the heating bed. If you want to print with ABS, the bed must be heated.
What are the disadvantages of PLA? Because if they were not, all would be printing with this.
PLA is harder than ABS, but because it is harder, it's much easier to break it. So I prefer print from ABS. It's more, flexible and so on. But of course, I have seen some stuff printed from polycarbonate, and you cannot destroy it. It's amazing material, but it's not so easy to print it. The material is much more expensive. The 1 kilo of ABS is 600 Czech crowns. It means it's $30 US. So it costs almost nothing. Okay, so I load my model. So I load the Gcode, and I print a small cat. Here you can see the Gcode, and let's try to start print something. Here you can see it takes some time to print it. Here should be some 14 minutes. Okay, let's try it. Okay, then we start printing, and during the printing we have a lot of fuck moments. So the most problematic part of 3D printing is calibration. So the first layer of the 3D printing, the nozzle must be almost on the touch with the bed, because the first layer must be, you know, little smooth to really catch good to the surface of the printed bed. If not, after some couple of minutes of printing, the product will go off the printer. It's a huge problem, and this is the biggest issue of the 3D printing. There are two technologies what to use. The first one, I'm using it now here. I don't like it. It's to use the Kapton. Kapton is a special tape, specially used in lithium polymer batteries, and the material is catched so heavy, so you can destroy the glass, because the surface below is the glass. So I don't like to use that, but it's very stable. It works very, very good, but you have the problems to take the product off. The second solution is hairspray. I'm using more hairspray than my wife. So you just use the glass and you put a lot of hairspray on it. There is at least half of a millimeter of hairspray. It works quite good, and it's quite easy to take the material, the finished product, off. Okay. So this is the first issue. This printer has another issue, because the heating stuff is so powerful that the heat goes up and melted the plastic before it goes to the extruder, and because it's too soft, the extruder cannot move it. So as you can see here, you will see it later because I invite you to come back. I have a fan, and I'm cooling this part so I can touch it. But the end has more than 240 degrees. So it's still, it took me, I don't know, 2 months to really learn how to operate it and how to print and how to solve the issues of the printing. You cannot use the 3D printer like that. You cannot use it for making some big series of some product, because the printing is very, very slow. So for example, this stuff, I'm using it in our bathroom. It took almost 1 hour to print it, and imagine to print 20 of them. So it's really, if you want to make 1 or 2 or 3 pieces of something, it works really, really good. But you cannot make 100 of them. It takes a lot of time, because this system is, it's by design slow. Of course, there are another printers using in industry to make some prototypes, special in car manufacture. This is the most common industry using the 3D printers, because you can print a lot of stuff for the car to test it, because the result has almost the same quality as the professional made. So you can test a lot of things for the car, for example. But those printers, those guys are using costs millions of US dollars. So it's not for the home usage. So if you are interested in it, come closer to see how it really works. Just don't touch anything almost everything is quite hot, or there is some electric power. So you can see how it works. It makes layer by layer, pushing the plastic out. So come here. Here we have some step motors. Those step motors work the same. They are controlling z-axis. The one motor controlling x, second y. Here you have Arduino Mega. Here is the electronics to control the step motors. And here we have the nozzle and the heater. This nozzle with this heater can make, but with different thermistor, can make almost 1000 degrees. So it's really very powerful and the damn expensive part of the 3D printer. But you know, you need it. Definitely.
Which one is it?
This one. This is.
Okay.
It's designed by Josef Prusa. And we have the fuck moment. It brings wrong, I think. We will see in a couple of minutes if everything is okay. You cannot print really small parts because the diameter of the nozzle. This is the what goes out from the nozzle. This one.
How do you control the how much actually plastic is inside it? Do you have to like if you want to have something hollow, do you have to make the model so that it has all these cross?
No. So the question is about the part inside.
How dense is the inside, right?
So here we go, the printer settings, and here we have Infill, and here you choose the style of the infill. So you have a couple of styles, and how many percentage of infill you want to use. The most common is the linear 10% or 15. It's most common, but for different, if you want to have some part which is very, hard,
rigid. Yeah.
so you can use the higher infill, or especially the honeycomb is, very very hard, but it takes much more time to print it.
Tell me, does the heat bed needs to be on all the time? Because
Yes.
when the part sticks to when the first layer sticks, then
when you're printing from ABS, everything must be quite warm. So special, you cannot print outside the building when it's lower temperature, or if you open doors and window in the room and you have this wind, it doesn't work, because those layers must stick together. So it must be kept warm, everything.
so putting all this in a box would be even better.
Yes, it's better, definitely. So this is the reason why the MakerBot is in the box, because it looks better as a design, and it helps printing. Yeah, there is some issue with the printing. You can see it looks bad. So you can kill it. You see the very nice fuck moment. So you can see it. There's some issue. I don't like this stuff on it. This one is better. So you can try to print on this one.
How much is the glass? It can be just ordinary glass? Or
Yes, it's just.
okay, so if you break it, no big
It's not the issue if you break it. Absolutely no issue.
Do you consider this machine better than MakerBot, or what's
It's
the advantage?
it's absolutely the same system.
Okay, so basically
If you You see, now I have problems. It doesn't push the plastic outside. The MakerBot and this, you have absolutely the same result.
And did you have a chance to look at the B3D printer, which is from Prague, like the retail-oriented stuff?
Which one?
B3D, B3D. I'll show you.
I know there is some in Czech.
They're
There
a
is.
startup. They make really nice design of the printer, but I don't know how it actually prints. So this is the important stuff.
As I know, in Prague we have there is a Prusa research company producing printers like that. We have on the Czech Technical University Faculty of Information Technology there is a 3D printer lab. They have a printer named Goliath. This is like that.
Oh.
And if you want to use the whole printer, it takes like weeks to print something on it. So,
Did you can print metal?
no on this.
No, on this.
It's theoretically possible, but the issue of the metal is that there is a very narrow border between the metal is hard or absolutely melted, and here you can here 10 degrees plus minus doesn't matter really.
Tell me, how do you adjust the vertical position?
Okay, the vertical position.
Because there seem to be no feedback, no end stop, and you take thicker glass. And
Okay, the most common way how to fix the Z-axis, you have a bumper, so just a button. Instead of button, I am using the hull sound. So using the screwdriver, I can fix the level.
But you have to fix it every time you
Almost every time.
change. Almost every time you put it on, you
Yeah.
put it out of the box.
Yes. And this is the big issue. So this one must be in perfect level. So this one must be in level. This one must be in level, and the Z-axis must be,
Has
set up.
anyone? Do you know if I know there is a community of people developing these machines. Has anyone considered using some kind of optical range meter
No.
to?
It doesn't. I think they tried it, but it really doesn't work perfect. So this is the best solution we have found now.
I see. Because I was thinking about some kind of optical,
Yes,
measuring because it seems with a diode or laser diode and then photodiode.
it really doesn't work. So this is the easiest solution. Definitely easy
So
solution.
setting it by hand every time.
Yes. Okay, if you don't move with the printer so much as me, because I am speaking a lot about 3D printing, because I
Yeah.
think it's cool technology. So I have it in my car, and if you move on Czech highways, so poor device, So I have to calibrate it almost every time I put it outside the car or bring back home.
I think one approach to this problem is using this end stop, but not installing it on the printer head. So and write some program that touch the table in few places.
Yes, I know, but this solution is too complicated. It's much easier to make it manually still.
Yes, it depends if you need it cheap or easy to use.
There is a big pressure on this RepRap project, so you have to be able almost do everything at home with any special equipment. So of course, I have this frame is from the metal, but you can make it from the wood, and from the wood you can make it very easy at home.
Is there a
Some
way
issue.
of diagnostics other than you can see it?
No, absolutely not. So you must see what's going on, because there is no any. Okay, if some only diagnostic which is here, if something goes wrong with the heating, the software automatically makes some emergency stop and everything is disconnected. Especially this is the huge problem of this kind of the heater because it's really so much powerful. It can melt it by itself. So I have seen some melted heaters and nozzles. Okay, you cannot destroy the nozzle because it's very, very high quality steel, but you can destroy this part and of course, ouch. Okay, it's hot. I told you, don't touch it. So you can destroy those cables. But the diagnostics here, almost nothing.
So how difficult is it to get this stuff? Like, is there a shop that you order it from, or just mail order?
Yes, you can order it on the internet. It's absolutely no problem. But the easiest, from my opinion, the really easiest way is to go to some workshop. Then you build your own printer. There is some supervisor to help you, to explain you how it works, what to do.
They
if
will
you have
have
issues.
a source.
Yes.
What is the nearest Delta workshop?
I know just about the workshops in Prague, which are driven by Mr. Prusa, who is the core developer of Rebra project. And we have the idea to make some kind of franchising to do this workshop around Europe. But it's still in just some discussion around that.
And also you can search for hackerspaces or fab labs.
Yes.
But
If you find some hackerspace here, so there is a big chance that there is someone who has the experience with the 3D printing, and you can go there. We have one hackerspace in Prague, one hackerspace in Brno, there is a hackerspace in Bratislava, and at least the hackerspace in Prague, they have at least 2 or 3 printers. So you can go there, print something, to ask them to print something for you, or you can go there to ask them for help when you are building your own one.
I've seen the sides of the objects are not very refined. And
It,
how does it work with the threaded parts like this one?
I have some issue with the printing now, so it's not printed correctly, but this is the standard quality.
Oh, okay.
So this is the standard quality of the printer. What you can do, because the ABS, you can melt ABS in acetone. So what you can do, you can take some big glass, put a little acetone on the bottom, put it on heated bed, so you create
Paper.
Acetone vapor. And if you put this part to acetone vapor and take it back, it really melts it a little, and it really looks like a glass. It looks really great, but it's some experimental technology, no?
Yeah, I read on Hackaday a few days ago. A guy used some kind of filler to fill those gaps, and then used a spray to. Of course, this technique is not good for mechanical parts which are supposed to work because this filler will
That's
will
why
be off. But
that's why I
if
was
you,
worrying about
Okay,
the screws.
you can use the absolutely same techniques you are using for making the plastic models. If you know the plastic airplanes, so on, because this material is ABS2, so you can use the same colors, you can use the same stuff to polish it and everything. But one technique is really to put it to acetone vapor, the one, or just to use the brush, put it to acetone and paint it just with the pure acetone, and it really goes a little together. The acetone goes inside, so all layers go better together. But you need to spend some time with this, when you want to finish it like that. The common example when you need a 3D printer is Apollo 13. Do you know the story about the Apollo 13, those guys flying to the moon? Yeah. And with the 3D printer,
would it
just print a new part.
does it work without gravity?
Yes. they will have 3D printer on IIS. Yes,
But FDM or SLS?
This one. This one.
FDM.
FDM, no. With the powder, it doesn't work without gravity.
Yeah.
This one works without gravity. And it's it's a huge boom about 3D printing now. So there are some proof of concept. For example, on the big warships, to have a 3D printer to print some parts, because they doesn't have enough space to have a spare part for everything on some aircraft carrier or boat like that size. So you can print a lot of stuff, and if it's broken again, you print it again. So you don't need to make something which will work for years. It's enough to work it for a month, because you can print another one, and so on.
Maybe you have to wait a few days.
Or a few days, it's enough to wait for the proper part or something.
Yeah, I mean to print it when you have
yes. But of course, I think the U.S. Navy can buy much quicker printers. Yeah, there are some issues with the printing. Now what you can see, because I'm printing a very small part, it's still melted.
Yeah.
You see it? It's still moving.
Yeah.
So this is the issue when you part something really small. It doesn't have enough time to cool it down, and it's still melted, and it really doesn't work properly.
Is it possible to somehow tell with software to generate smaller parts move slower?
Yes, it's possible. So it really depends on the slicer. I will set up the slicer. The easiest solution is to print more parts. This is the easiest and the best solution. So for example, if I want to print diskette only one, it's better to print 2 or 3 of them, because it will not melt it.
Or somehow tell the software
or really slow down.
Move on layers that have very little cross section to move away. Wait a bit.
Yes, but ABS is very cheap, so it's better to print more parts.
Yes, it's much easier. So here you can see here I can slow down, or so on, and here we have a broken cat. So there is some issue. This is the typical issue when the filament doesn't go through in the proper way. I don't know what's happened. It's ugly cat. No, it's a Resident Evil cat.
There's nice gallery, I think, on Flickr with broken printings.
Yeah, quite nice. It was a few days ago at Maxim, I think. They
So, how to tell more? I think you need 3D printer, believe me.
I'm trying to build one for myself.
So I have it since last December. Of course, I'm printing a lot of stuff for kids or for friends, some fun stuff. But really, at home, I use it 3 times to fix the shower of my mother, to fix bath at my home, and to fix some chair. And it's really much easier to, for example, to fix the shower of my mother. That's a very small part, really broke down. And the shower is old, so it haven't been in guarantee. It's, if you go to shop, they try to sell you this big part with everything just to change it for a lot of money. And it took me, including the printing, it took me 25 minutes to make a model, to print it. And the result, the material, was like nothing, like cents, or nothing.
Yet another way to use such machines is to replace to take off the extruder and use it as, for example, drill for PCBs. Yes. And this is a universal. In practice, this is a universal.
Yes, you can do it. So you can have a drill here. It will work. It's not good area to use it for PCB. For milling, yes, but to
the torque needs to be little because
Yes.
Because of the belts. Belts are not enough to
Yeah.
push. That's what I know. But few other uses I've seen.
So you can imagine that the 3D printing is really now big thing because in Windows 8.1 you have a direct support for 3D printing.
How so? What does it mean? You've got
So if you connect MakerBot, for example, so you can direct print it. So you
So
have
it's-
drivers for 3D printers inside the Windows 8.1.
So the funny stories about fixing the models and not really working.
It's a lot of I show you something. It's a lot of
Yeah.
okay. Thank you. It's a good hint. So I show you what can happen. To maybe go look at the screen. I try to show you one thing, which is really mega fuck off. How much time I still have? 15 minutes?
yeah, probably.
So it takes some time. So I want to just show you what can happen if you download some 3D model from the internet. What can happen? This one. So if something like that happened to you, so it means that the model itself is broken. So if I load it here, so you see, it looks really strange. You see this blue part, so it's not correct. So you have to use a special application, and I forgot the name. Just give me some time to find it in my mess on computer. Hey, what is the name? This one.
Doesn't Windows 8 have tab completion?
Yes, but I don't remember the name, so it doesn't work for me, you know. So this is the part how it should look like, but the typical issue is that the string grow mesh, it's naruby, it's turned from the inside out. You like if you turn the shirt, you know, sometimes happen because it's not properly created from some application. So you need to repair it using this typically with the netfab application, and after you repair it you must go again back to slicer, delete all. I have this repaired version, export Gcode, it takes some time again. You need a lot, really powerful computer to create a Gcode. It takes a lot of time. If you have slow computer, it can take, you know, tens of minutes to create it. Especially if you have some big part like that. So it takes some minutes here. It's really scary, cat. and here you are, this is the proper part. And it will take, the print of this is 2 hours 45 minutes. So it really, the printing is quite slow, especially if you want to print some big part. So it really takes some time.
So if I want to make for myself a 3D printer, I need to find a very, very good friend
To print it for you.
to print about
This is the part. This is the part of Prusa Mendel I2. So those part, it takes hours to print it. So you need to really find someone who has enough time to print it. And especially if you don't have some good stuff to add some material, it's very easy. You can make some knot on it. So you need to control it and so on. So it's still quite tricky, this 3D printing, but if it works, you can do a lot of interesting stuff with that, definitely. Okay. So some questions?
How many tries does it usually take to get a good product?
If it's some simple stuff, now I can print it for first time, it's no problem. But for example, this part, I tried to print 5th time, still doesn't work for me. You know, it really depends on the model, it really depends what you want to print, because here you have what is stupid on this part, you can see it here. This small stuff is connected somewhere up here using the bridge, and this is the, if you need to print on the in the air, so you make some bridge, it's very tricky, still very tricky. Of course you can make some support material for that, but still it's very tricky to print those kind of the parts. So I tried it 5th time and doesn't work. But for example, to print stuff like that, it's a piece of cake. It works on the first try. It's no problem because it's very simple. It's not so big. It's really flat, so it's not problem. This one didn't work because of it's too small and it was melted. This is the issue of this cat. Print 2 cats, it works. It's no problem. And again, this part I printed 2 of them because I needed 2 of them. So the print was very easy, just first try. This is the issue with melting. Okay, some more questions? Okay, if not, build your own printer. Believe me, you need it at home. It's a lot of fun with that. And have a nice day, and there will be some party on the what is the name of the street here? Mariacka? It's close here, as I know. Perfect. So it's local Stodolní. Okay, so see you evening in the pub. Bye guys.